Here's an example of finding the magnitude of direction of a vector, and in this case we're going to use this formula here. There are like 3 different ways of doing this. So first off, v is negative 4i plus 8j. If we were going to draw that, that would be in the second quadrant, so we get this vector going out in this direction. Let's make it a vector. Alright, and if we're going to use the formula here, it gives us actually 2 possibilities of figuring out things. We're still going to need a right triangle out of this. I'm going to drop an altitude. We're still going to need a right triangle out of this, so I'm going to drop an altitude to form a right triangle. Label the sides appropriately. So this side is negative 4, this side is positive 8. And to find the magnitude, obviously we're going to do a squared plus b squared's square root. So that would be 64 plus 16, which is 80. So this side will be the square root of 80, which is 4 square roots of 5. So we know what the magnitude of v is. The magnitude of v is equal to 4 square roots of 5. And again, there are 2 ways of coming up with this angle theta. One of them is to use the tangent inverse, just using the 8 and the negative 4. Another way of thinking about it is the magnitude of v times cosine of theta has to equal this negative 4. So the magnitude of v cosine of theta has to equal negative 4, because they're both in front of this I term. So they have to be equivalent. So I'm going to leave it as the square root of 80 times the cosine of theta is equal to negative 4. So we'll have cosine of theta is equal to negative 4 over the square root of 80. And we'll find that theta is approximately, after cosining inverse both sides, 116.6 degrees. What's nice about this is you can actually check your work and do the magnitude of v times sine theta and set it equal to 8. The only problem is when you do the inverse, sine inverse only works in the first and the fourth quadrant, so you're going to get an angle down here. I'm sorry, it'll be a positive angle. You'll get an angle in the first quadrant, and then you have to reference it into the second quadrant, and it does come out to be 116.6. And the same thing with the tangent inverse. Tangent inverse works here in the fourth quadrant, and you'd have to reference the angle. The cosine one you don't have to reference if it's in the second quadrant. So that's why I chose it for this one.